Okay, let's talk about the arteries and the veins. And I'm actually going to talk about both of them kind of simultaneously because there's some really interesting differences I want to point out between the two. We know that they're both vessels, but there's some really important differences between how they work and what they do. So this is your heart, and coming off your heart is the aorta. And before this video, I've been drawing the aorta quite differently, kind of showing its branches, and here I'm showing it kind of stretched out. And I'll show a few of the branches, but really the point of the drawing is not to make it anatomically correct. You can tell it definitely is not anatomically correct because that wouldn't make any sense at all to have blood going off to one side. But really I want to show you a concept in this video, a few concepts actually. So here we have, let's say, the veins, and I'm going to stretch that out as well. And let's imagine that all of the veins are dumping into this one final vein that gets back to the heart. And so I'll draw the branches kind of coming in to the vein here and here. And we know that the arteries and the veins are trying to get blood out to the capillaries. So let me show you what a zoomed in version might look like of the capillaries. So we've got, let's say, some capillaries here, and maybe some here, and here. And you know, of course, in real life, you don't have 3 sets of capillary beds, which is what I'm drawing here, but really you have thousands and thousands, right? And let's not forget, that these capillaries are basically found in different parts of the body. So you might have, for example, a bone and some capillaries in the bone, and you might have the second capillary might be going to your face. Let's say even specifically your nose. And this third capillary bed, that might be going down to your foot. So you have blood in your foot. So you have different parts of the body all getting capillaries, and the blood is going to start at the heart, go to the capillaries, through the arteries, and then return through all of those veins. And we've kind of lumped it together. And what I want to show you now is that this, very, very simply, is the systemic circulation. Systemic circulation. Now, of course, you know that there's also the pulmonary circulation. So what does that look like? Let me draw that out here. Pulmonary circulation. So pulmonary, means lungs. And I've shown you previously in another video that there is blood going to these lungs in a very low pressure system. So we talked previously about low pressure and high pressure systems, and now just remember that this is kind of how it gets there. You have the deoxygenated blood, or the blood in the blue vessels kind of going up like that. And this would be the pulmonary artery. Pulmonary artery. I'll write ART for artery. And we have the pulmonary vein, bringing that blood back to the heart with oxygen in it. Pulmonary vein. So that's your pulmonary circulation. So you have pulmonary circulation and you have the systemic circulation. And I'll get back to why I drew the pulmonary artery in blue and pulmonary vein in red in just one second. Let's just put that on the side for a moment. And let's get into exactly how to think about arteries and veins in general. So in general, I think of arteries as taking blood away from the heart. That's probably the easiest and most clear way of figuring out what an artery is exactly. So arteries are taking blood away from the heart. So let me just draw a little arrow here. And veins are bringing blood back. And so this becomes our first point. Point number 1. And this is the point of difference between the two of them, is the direction of flow. And even if you look at the pulmonary system, you can see that that remains true, that the arteries are taking blood away and the vein is bringing the blood back. Okay, point number 2. Now you see that the arteries are drawn in red for the most part. And so usually arteries have oxygenated blood that they're bringing out to the tissues, and then the veins carry the deoxygenated blood that they're bringing back from the tissues. So point number 2 is really about the color. And so let me write that in here. So this would be like a little red blood cell with hemoglobin in it. And this is a little red blood cell, still called a red blood cell even though its color is more blue. But it's still got hemoglobin in it. But the hemoglobin down here actually doesn't have any oxygen left. And so the color looks quite different. So the color of arterial blood is usually red because of the fact that oxygen is bound to the hemoglobin, and less oxygen is bound on the venous side, so that's why it turns blue. Now, I want to just put a little star there because that's not always true. And you can see where clearly it's not true is over here. So let me star the pulmonary circulation, where you can see that the pulmonary artery and vein, I'll star that just to really emphasize the point, are actually the reverse of what I just said, right? Because the pulmonary artery is actually going to carry the deoxygenated blood, and the pulmonary vein is carrying the oxygenated blood. So clearly that's the reverse of what I just said. But that is one exception to the general rule, which is that arteries definitely look red and veins generally look blue. Okay, so those are 2 points of differences between the arteries and veins. Let's keep going. So now you know that arteries are high pressure, right? Because the heart is pumping the blood out, and it's going to be under very, very high pressure. And so I kind of think of the arteries as being like a river, a fast-flowing river. So you can think of this as fast-flowing, high pressure. So that is the third difference. So this is a high-pressure system. Third difference is that it's a high-pressure system. In fact, maybe I'll even emphasize the point by writing the word very large. High pressure. And actually, the other thing we think about with arteries is that there's not so much volume in the arteries. So if you actually looked at, let's say I froze time and I actually try to figure out where all of the blood was located, not too much of it is in the arteries. So it's actually a very low volume system. I'll write volume very small. And the veins are the opposite. They're kind of a large volume system, and they have really kind of low pressures. So I'll write pressure very small over here. And if you actually figured out what percent is where in terms of the amount of blood, about 5% of the blood at any point in time would be in the heart. And let's say about 5% would be in the capillaries. And then about 10% or so would be in the lungs. So what are we up to now? We're at 5 and 5 is 10, 10 plus 10 is 20. And then we have another about 15% in the arteries. So about 15%. So that's actually not too much blood. And so the remaining, 65% of the blood is actually in the veins at any point in time. So that's remarkable, right? About 2/3 of the blood at any point in time is actually sitting in all the veins combined. And so the way I've drawn it is really not really the best way to draw it. I should really erase this and really redraw this to make it much more accurate. It should look a lot more like this, right? Like a big, giant lake of blood. And so this is actually how to think about the veins. It's actually a very, very low pressure but high volume system. So that might be the third point I'll bring up on the blood side, or on the vein side, is that it's a high volume system. So high volume. Now, we've talked about the direction of flow. We talked about the fact that one side carries more oxygen than the other. And we've also talked about the fact that the arteries are a high pressure, low volume system, and the veins are a high volume, low pressure system. So what are some other differences? So one other difference is that in the arteries, you actually don't have any valves. Now, I don't know how to label that to make it super clear, but let me just find some sort of open spot here and write number 4. There are no valves in that arterial system. Whereas on the venous side, you actually do have valves. You have these valves that come together. Actually, make it very clear by making the two sides touch. And the blood kind of goes through like that. So you have these valves that keep the blood going in the right direction. So that would be the 4th point of difference between the two. So you have these valves. And you might get confused because you think, well, doesn't the heart also have valves? And it does. The heart also has valves, but the veins have a different type of valve, and that's actually to keep the blood flowing in the right direction. You can imagine that you probably don't even need that on the arterial side because the pressures are so high that the blood is forced to go one way. Whereas in the veins, because it's kind of like a giant lake, water can kind of swirl around and around and around, and so it's helpful to have valves keeping it going in the right direction. So that's a 4th point of difference. So now think about the fact that you might have a break in the arterial system. So let's say that you have an accident and you cut an artery, or a big artery, let's say. What would it look like? So if you have a break right here, you would actually have like a fountain of blood coming out right there, because it's under such high pressure that it's just going to spew out, right? And so this is basically what it looks like when you actually cut an artery, again, because of the fact that it's under such high pressure. And now on the venous side, or on the vein side, if you have a break, it looks really different, because if you have, let's say, a break right here, you'd actually get kind of a pool of blood just locally before it clots off. Because again, you have very low pressure, so it's just going to kind of quietly pool, and you might get a bruise right there, but it certainly won't look like a fountain of blood. And so that's actually another final point of difference, which really gets back to the high pressure system on the arterial side and the high volume, low pressure system on the venous side.